Okay, I'm going to do a local computation for curvature. So K again was equal to this guy. So we had a connection on a vector bundle, and then the notion of the covariant exterior derivative allowed us to talk about this guy, this K, from E to omega 1 as tensor E. And let me tell you, so what we can do, this is for 2 here. Let me just say something else. So what we can do, given so this is what we call the de Rham curvature. In local coordinates, so recall in local coordinates, we have the connection 1 forms. So let's say, let's pick a basis for E, let's say V1 up to VR, so it's a vector bundle of rank R. So this is coordinates for V, and then we can take coordinates for so these are going to be derivatives for theta 1 up to theta n. These are going to be like tangent vectors for T, so these are going to be basis, a local basis for derivations. And so so in local coordinates, we wrote out what the connection looks like. And we had these connection 1 forms, and again, I'm going to use Einstein notation. Sorry, that's not right. This is omega gamma beta tensor E gamma. And so we thought, we viewed this as kind of, let's say V. Okay, and we viewed this as kind of a matrix multiplication for this connection 1 form. And, okay. So when we write it out in coordinates, and then so what we can do is we can take K and we can write V beta, and this is actually going to be here omega gamma beta tensor V gamma, and these guys here, so these are the curvature 2 forms. Okay, and so this is for this de Rham curvature. And I want to give you a local expression for this. So let's recall that that the expression for these omega gamma betas are really well, maybe I don't need this. I don't think I need this. I don't need this expression. We can write it out further in terms of Christoffel symbols, but I'm not going to do this. We can do it later when we need it. So let's write out what we had here. So we did have connection 1 forms. I am going to write them. So the connection 1 forms allow us to compute what this is. So this is omega gamma beta tensor E gamma here. And what I'm going to do is I'm going to apply that to this. So we have now omega gamma beta tensor E gamma. And now this is going to look like magic. So here, this is a summation here, and it turns out that that this operation is linear. Okay, so I'm going to not write down a step, but it's implied in the notation is that if I were going to write a sum here, that I could bring the sum out. Okay, so that doesn't matter. So now I'm going to apply the definition for this omega 1. So this thing here is d of this guy minus, since it's degree 1, wedge the exterior derivative of this guy. And this becomes d omega gamma beta tensor E gamma minus omega gamma beta. And now I'm going to write out the expression here, omega alpha gamma tensor E alpha. And now we have this expression. So let me just copy what that said again. Okay, and so here's what we have. Uh, so this guy here, now what we'll do is we'll replace these gammas everywhere with lambdas, let's say, so that we can collect things. So and then this alpha will be a lambda, gamma, beta, wedge, omega, alpha. Let's say lambda, gamma. So that's a free variable. And so now we can distribute this. So this is D, and so now these are just one forms, so we could flip them and get a minus. So this is here, minus, let me just not do that yet, which here, gamma, or let's like so, tensor E gamma here. So then this is the expression for, so this is the expression for this is our curvature 2 form. And we find that omega gamma beta, so this is equal to, let's see, so d omega gamma beta, and now I'm going to flip them, plus omega let's say omega, let's say gamma alpha, wedge omega alpha beta, like so. Okay, so I flip them and then I change the sign, and then so this is the expression that we have for the curvature 2 form. Let me say something else, is that we can, with these two guys together, this looks like a matrix multiplication. Where we're multiplying matrices using the algebra structure for this ring. So we have R by R matrices in here. And so we're really thinking taking degree 1 things to degree 2. And so this really sometimes is expressed as omega is equal to d omega plus omega wedge omega, like so. And so these are matrices of 1 forms. Okay, I'm going to stop the video again and then collect my notes and continue.